Today, we are going to demonstrate the force of friction. Now, friction is the force resisting the relative motion of solid surfaces, fluid layers, and other material elements sliding or rubbing against each other. Friction is mathematically very simple to define. The force of friction is equal to the coefficient of static or kinetic friction multiplied by the normal force. The normal force is always perpendicular to the surface in contact and is a measurement of how hard the surface is pushing back on the object. The frictional force is always in the direction that opposes motion and is located where the two surfaces meet. Here we have a setup where this wooden block is attached to a spring scale, which will help measure the force necessary to pull the block across our surface. As we do this, notice the change in force the instant before we move from a static object to one that is in motion. So what is the coefficient of friction? Well, essentially it is the surface or fluid's ability to grip onto a body it is in contact with. It is usually mathematically denoted by mu sub s for static and mu sub k for kinetic or sliding friction, and is unitless. The object will remain at rest until the outside force overcomes the frictional force, causing our object to slide. As it slides, there is still a frictional force, but our coefficient of friction is different, as it is a ratio of the force necessary to move one surface horizontally over another and the pressure between those two surfaces. In this next scenario, we use the same two surfaces, but this time we lubricated them both with WD-40. By doing this, we have changed the coefficient of friction even though both materials used remain the same. This is commonly referred to as lubricated friction. Note that this time, the force required to set the block in motion is more than the one previously shown. But once sliding, less force is needed to keep the block moving at a constant velocity. Using the forces found during the demonstrations, we can now determine what the coefficients of friction are by using the equation for friction. The normal force used in our equations is equal to the weight of the block, which was calculated as 18.74 newtons after measured at 1,910 grams. I hope this demonstration has shown you how you can find the coefficient of friction for a static or kinetic system by using only the normal force and an outside force and the equation of friction.